Okay, so we're starting with graphing distance, speed, and time. And it's important to know why we bother taking the time to graph. If we're doing a sketch, that's a quick look of what's happening, a quick picture, okay? But when we graph, we can do that in order to analyze the data. So if we graphed, we could actually find the slope and find out what the speed would be. Graphs show us how one variable is related to another variable. So if we had a graph and the line looked like this, we could say as your time passes, the distance away from home also increases. So both of those increase. Here, we could say as time passes, the distance towards home is going to decrease. You're going to get closer and closer to home. So that's what we're talking about, how they're related. Data plotted on a graph is easier to interpret than reading numbers. Again, it gives you a clear picture. Trends and patterns are more obvious on a graph, and it's much easier to draw conclusions. So kind of like a sketch, you get the picture of what's happening, and it's easier to look at the trends. Okay. First thing we have to know the difference between an independent and a dependent variable. If we're looking at the independent, that's called the controlled variable, and that word you might want to underline. And it's always plotted on the x-axis or the horizontal axis. It's a controlled variable. And it is set by the experimenter. Okay, the person who made up that experience or the experiment, they're saying, oh, maybe I am going to find out what my position is, my distance traveled every 1 second. Or maybe he'll say, I'll find out what it is every 3 hours. Okay, so it is a controlled variable. It's an independent variable, and you always find that on the x-axis. And if you have time, it's not always going to be time, but if you have time as one of your variables, time is always going to be on the x-axis. It's always considered the control variable. Then we have a dependent variable. It is an uncontrolled variable. Okay? It is always plotted on the y-axis or the vertical axis. So this dependent variable is always the measured quantity. It is the measured quantity. So what would happen here is maybe I'm going to measure the distance every 1 second. And so 1 second happens, and then I measure distance. 2 seconds happen, and then I would measure the distance. So independent is set by the experimenter. It is the controlled variable. Dependent is your measured quantity, and it is the uncontrolled variable. Write a title. When you write the title, you will always write it in the form y versus x. You don't actually write y versus x, but whatever is on your y-axis, perhaps it's distance, versus whatever is on your x-axis. And in this case, it would be time. Okay? So when you do a graph, you will always label your graphs like that. Whatever's on the y versus whatever's on the x. So you could say distance versus time of a truck, a red truck, if that's what the example was. That part, it doesn't matter, but you have to put this in. Okay, then we have a scale. There are two calculations to be completed on the back of your graph. So when you do a graph, you want these. And in order to have a scale, when we do scales, we want our graph to be as big as possible. And that means it has to at least be a half a page in size, okay, at the very least. So, how are we going to decide what the scale is? You take the number of squares on the horizontal axis, so you're going to draw a line, and you're going to find out how many squares are on that. Divide it by the number to be, the largest number to be plotted on that horizontal axis. So you might have 15 squared, and there are, the largest number is 60. So you take 15 divided by 60. Same thing for your vertical. It says the number of squares on the vertical axis, and you're going to divide it by the largest number to be plotted. And it says the answer you get must be rounded down. If you round up, you're going to run out of squares. Okay, then I have to label each axis. I have to put the variable, its units, both the x and y axes. So label, we also want name. So make sure you stick that in there. Label name, variable, and units. So perhaps, and again, I am drawing this with a ruler because it's, and it would be on graph paper. You have to have it on graph paper for a graph. In order, if I had a sketch, I could just say D and T. But if I have a graph, I'm going to say distance. I'm going to write the symbol, and then I'm going to write units. What did I measure that distance in? Meters, centimeters, kilometers, whatever. Time, well, I'd have to write out the word time, and perhaps the units for my time was a second. Okay? So it's important that we write the word, the symbol, and the units. Oh, I think we're back here. Back down a little bit. Okay. Number 5, we want to plot the points. We want to put a dot and a circle around your points. So again, perhaps this is our axis. If I wanted to plot my point, I would then put a circle around it. And that circle just indicates that there is some error with that point, because I still have the thickness of my pen or pencil. I have graph paper that is not 100% or exact, 100.0000% exact. So I want to make sure I plot them like that. And then it says draw a best fit line. Be sure to be very neat. Use a ruler. Well, use a ruler if the line is straight. So let's kind of, I'll put a couple of examples here, just picking a point like that. So perhaps this was my set of data. And if this was the set of data, this looks to be fairly straight, okay? When I do my best fit line, the idea is to put as many points on my line as possible, and then to try to get as many points above and below the line, okay? So I couldn't just do one up like this, because I'd have 3 points on the line. That looks good. But then all of my other points would be below my line. So that's no good. So I have to kind of make it maybe like this. yes, I only have 2 points on my line, but I have 2 above, 2 below, and they're approximately the same distance away from that line. So my best fit line in this case would look something like this. Okay, best fit line. So again, when I do a best fit, I want to have as many points on my line as possible and also have as many points above and below the line and about the same distance away from the line. Okay. Notice that when I drew my line here, I didn't go through the circle. And we do want to stop so we don't go through the circle because then we could cover that point. Okay. Now, notice I did use a ruler and it was a straight line. Perhaps my line looked like this. Let me change color again. Like that. That is definitely has a trend, but it is curved. Okay, so I wouldn't want to do a straight line here. This, if we had a distance time graph, this would indicate that you're accelerating, you're speeding up. So a straight line would be saying, oh no, the speed is constant. And that wouldn't be true here. So when I do this, I have to do a smooth curve. I do not do dot to dot, okay? I don't play that game here. I try to do it as smooth as possible. So for me, I do it quite light the first time. It's hard to tell with this. And I also go through those circles and then go back and erase that. Because I just find if I stop and then start again, I don't get that smooth curve. And it kind of looks like I'm doing dot to dot, and that's no good. So I would do something like, let's see what we could do here. Oh, a little bit off. So if I had a pencil, I would just erase that. The second one is better. Okay? And then I would go through and erase the values, the little line inside my circle. Okay? Smooth curve. That's what you need. Okay. And the final thing we have to worry about is your slope. Now we talked about slope already. We said slope is equal to rise over run. We said it's equal to change in y over the change in x, which is equal to y2 minus y1 over x2 minus x1. And again, those formulas are on your equation sheet. Okay, so you don't have to memorize them. So it says show both the formula and the data used on the front of the graph paper. Okay, so you're going to have to, if you're asked to do slope, do the calculation on the paper. The vertical distance is the rise. So this is your y value, kind of obvious there with the change in y. The horizontal distance is your run, or the x value. And then we just do slope. Okay, so that's it for now.